Hi everyone, welcome to the third block of the people track for TIPE 3D. Thanks for joining us. Today or next we have a conversation between Sophie Dower and Malini Ducey on women in automotive and additive manufacturing. So Sophie and Malini, I'm just going to call you up to present. Please you should get a little alert. Wonderful. We've got Sophie and Malini. Excellent. All right. I'll hop off the screen now. So take it away, the both of you. Can't wait to hear what you've got to say.
Awesome. Hi, how you doing? All right. So I am just going to kick this off. Malini, if you want to introduce yourself real quick, and then I'll give my introduction.
My name is Malini Ducey, and I'm currently working at General Motors in the additive manufacturing. Most of my background prior to additive was really based on traditional manufacturing, mainly in plastics. And I worked in various companies, some of plastic manufacturers, then the plastic formulators, then the injection molders, then finally General Motors, where again, I was in injection molding, made the transition to additive about 4 years ago. And mainly, again, been on the polymer end, a lot of FDM, a lot of applications, but now I'm in a role which all the different plastics additive technologies, and we are working together with the powder technologies as well as the resin, as well as the filament, and influencing the machines of tomorrow and the technologies of tomorrow, applications and support GM and additive as a whole. Sophie?
Awesome. Thank you. So Sophie Dower, I'm an applications development engineer with Carbon. I graduated from RIT with a mechanical engineering technology degree. From there, I had actually interned at Fast Radius during my co-op time. Went into a full-time position at Fast Radius post-college. Got to work on a lot of really cool applications there. It was also my first introduction to the carbon printers. From there, I ended up at M. Holland Company, where I was also an applications engineer. Got to work a lot with plastic injection molders, a lot of applications with tier 1, 2, 3 molders in the automotive industry. I also happen to be a massive car nerd, so I've just inherently been drawn to anything in the automotive industry. After M. Holland, I ended up at Carbon 3D, and I've been here since March of last year, where I'm also in the automotive industrial team, and I get to work on a lot of really awesome applications and OEMs, and help get products to large-scale production. All right.
Thank you. So we've received a lot of questions from the outside, and as this panel, where we're women dedicated to additive manufacturing, coming from really two slightly different areas, one being the OEM, automotive, more application driven, and one actually the technology area. And so it's going to be interesting, and as we go through this panel, we'll try and answer a lot of the questions that were posed as quickly as we can, so that we can leave some time open for any additional questions that you may have. So I'll begin. Sophie, at Carbon, tell us a little bit about your day-to-day. What does a typical day look like for you?
Yeah, so great question. Being in additive manufacturing, it's constantly changing. But one thing that doesn't change is we get to work a lot with OEMs on like really meeting with OEMs, talking through different applications that they have, kind of sorting through which applications may benefit from additive manufacturing, not just what can be done with additive manufacturing, but what would truly benefit by what additive manufacturing can open up, whether that's through supply chain or performance benefits. So it's really a lot of talking with them about their performance metrics, and then running in-house material testing and foam testing to figure out where they're currently at, and then improving their product using the capabilities of what additive kind of opens up. I would say, other than talking with customers and doing a lot of like performance testing of foam, I also spent a lot of time in the lab. So that's been a lot of fun to actually get in on and work with the carbon printers and actually post process the parts, figure out how far we really can push the technology. And yeah, it's just been a really good time.
That's really exciting knowing that you get, a pulse of everything that's happening. You get involved in every aspect of it. And I think that's the beauty of additive, at least where it is today, that you do so many different things within additive. So it's not just the role that you're assigned to, but really you're doing it all, right? Just getting a flavor of all of the functions within additive. And that's very exciting. So thank you.
Yeah. So obviously GM has a beautiful additive facility from what I've heard. When GM jumped into additive manufacturing, what were some of the challenges that you faced coming from injection molding into additive manufacturing? And then is there any project that stands out in particular to you that like you enjoyed the most or was the most difficult that you worked on?
Sure. Additive still is challenging, right? Even though we started many years ago. And yes, we have a really nice facility which houses all of these different technologies. We have a lot of process engineers, a lot of application engineers, all somewhat housed in the same area. So there's a lot of interaction. But I would say challenging wise, even it's a large company and it's made up of several different units or different organizations. And each one of them is independent in a way. They're interconnected in a way. So for instance, there's a group that deals with doors, some with fascias, some with all of the manufacturing aspects of making a car. And the big challenge was to really reach out to each group and change their mindset from what they know of what they've traditionally done to utilize additive, which is what we all face, but we faced it within our. And furthermore, the big challenge was I was getting involved with what we call manufacturing tools. So manufacturing tools are any aids, anything that will help you on the plant floor. And in working with them and creating tools for the plants, it's a challenge right there too. They are used to traditional metal tools. Furthermore, to compound the challenges, GM doesn't design the tools or doesn't make them either. It's our supply base. So we had to work base where people are experts in what they do and try and bring in new age knowledge of, hey, there's a better way to do it. So we had to tread carefully. At the same time, important additive, we had to determine in all the presentations we were making, what are your pain points? Where can additive really be of value to what you do today? And in the discussions, which some of them were, we were able to pick that up. And each time we would find a pain point and try and find an application that would help it. We started with small things. We didn't want to take big risks at first, and we wanted to get some success under our belt, confidence to get some learnings. And so that's how we started with our supply base as well as within GM and navigated it that way. And very quickly, as they saw the quick successes, as their confidence grew too, the tide turned. Instead of us pushing applications and saying, hey, this is where it can work, they were coming forward with so many applications and say, what about this? Hey, let's try it this way. So we found success very quickly after that. To answer your other question about one of the projects that I would say we as a team would be proud of is there were some handheld um, fixtures, additive fixtures, I would call them, which again traditionally are made out of aluminum or metal, and they would vary anywhere from, I would say, 13 to 25 pounds each when they were made out of metal. And these were what we call stud check fixtures. So the basically they are checking studs on profiles which have different shapes. And again, traditionally that's made out of several different components which are machined independently and then assembled, and then the resulting thing is heavy. So it was difficult for the operators to use it day in and day out. There weren't just one or two, there were 92 unique tools, some of which were like longer than 6 feet. So we worked with a large team, ergonomics, operations, quality, everyone was involved. And we one by one designed these out of additive. And the reason I'm proud of it is because it really speaks to the attributes of additive as we know it. There was lightweighting. We definitely reduced lead time, reduced the overall cost. We consolidated components. We conformed to the profiles. Really made it specific to the job at hand. So everything you can think of that additive can do, these tools kind of captured that. And once they received them at the plant, this was our large SUV and truck plant, which is one of our key plants. So we were a little nervous about that too. But once they received it, there was just a one word response that we got. They said, "These are fantastic." And then, that's all we needed to hear. So that's something we were really proud of.
That's really, really awesome. I mean, along with like lightweighting, there's obviously like cost savings along with using additive manufacturing, but lightweighting a product like that that's being used all the time by like technicians, like you reduce risk of injury. Like there's so many additional benefits as well, other than just creating the part. So that's awesome.
Thanks.
So can you tell us about any challenges you have faced working in a male-dominated industry? So especially considering both additive manufacturing and the automotive fields have a significant male presence, and how did you overcome some of those challenges you saw?
So over the years, I've seen the industry as a whole become more open to women in general. But back in the day, it wasn't so easy. I was just a girl, and oh my goodness, I've got this young engineer, and she's a girl. Will she really be able to do this? What I would say is at each point, and I didn't know much going in either, in each of the new technologies I would enter, it's really important to, it's true when they say you got to work doubly hard, but you got to do it initially to get the credibility, to be able to show that you are capable. And at each point, I had to do that repeatedly. And once you have it, then there is no difference. No one views you differently. But I've seen a significant change in the industry, including automotive, including General Motors, where there's a large amount of inclusivity. I mean, there is diversity, inclusiveness. All of those are not just buzzwords. They really are there to stay, and we see that in our interactions, in the way we are approached, in the way we are assigned roles. It's a lot different than what it was before. So the young ladies who are listening, the people before you have paved the way. This is for you to take on and really maximize it. In additive specifically, I would say it's still relatively a new field. So this is the chance that I would say women have to be at equal footing. There aren't the male dominated spheres that exist within additive. We were both entering it at the same time. So this is a great field to be as a woman. But I'm going to ask you, Sophie, in I can imagine in the early days, both in your engineering courses in college and when you first entered the few women as well, what was that like? What was your experience?
Yeah, so I will say at RIT, when I first got to college, there's definitely some pushback from some older school professors. There was one day I was sitting in the engineering wing, And I had a professor come up to me, and they looked at me and they're like, "What are you doing here?" And I was like, I'm waiting for my fundamentals of engineering class." And they were like, "Oh, I give it 2 weeks," and then walked away. And I made it my goal after that I was going to graduate from RIT with an engineering degree, and I was going to look them in the face and be like, "I stayed, I'm here." So there, which that was, I will say, that was few and far between. It does happen, but one of the best things that you can do is just to prove them wrong. Just to keep fighting through and keep making your achievements, making goals for yourself, getting to those goals, and then just continuing on, because it's a fantastic feeling proving people wrong. Um, when I was in college, there was definitely, I mean, there were some classes where I was one of maybe 10, or like one girl out of a class of like 15 to 20, if you're talking about labs, or for larger size classes, there might be 5 to 10 girls in a class of 50 to 75. So mechanical engineering does tend to be a bit more male dominated, because you are looking more, at least in my degree, it was more automotive focused, uh, where people tend to either go into automotive fields or HVAC fields, instead of like environmental engineering, which tends to be a little bit more neutral. Um, so there definitely came with its challenges then, but like I said, it just kept setting goals and meeting those. And I'm still friends with a lot of the girls that I went to college with as well. And it's great to see all the achievements we've all made. Some of them are doing some really awesome stuff as well, which is great. Um, so when it comes into getting into the industry, kind of what you said about how men and women are kind of entering the additive field at the same time, I could not agree more with that. Um, I think getting into the additive field is riveting because it is so young. It's constantly changing. Diversity and inclusion seems to be just a trending topic with so many of these companies. I know Carbon takes diversity inclusion like incredibly seriously. I mean, we've got tons of programs that we do internally to promote diversity and inclusion. A lot of push to get women into leadership roles as well, which is fantastic. Um, and it's a really supportive environment. So it's just been really great, and I can't recommend it enough. I've got a niece who wants to get into a STEM field, and I've been pushing her into trying to get into additive manufacturing as well, just because she finds a lot of interest in it. Um, but it's like talking about women and being pushed into leadership roles and getting into leadership roles. I just want to talk a bit about General Motors CEO Mary Barra. So it's a powerful statement to have a woman at the head of a car company, like let alone a CEO, but at the head of a massive OEM. So what do you make of her leadership style, and like what tone has it set for the company?
So Mary Barra, when she first came on board, I think she surprised just about everyone, probably herself too. And being in really the most traditional male-dominated field, and it's General Motors. You know, at one time it was the number one company, and then now it's a woman running it. I live in Dearborn, Michigan, which is the country, Ford country, really, even though I work at GM. And I would hear from all my friends and neighbors, oh, she's not going to last, right? That's what people thought, that she was just put there for a while. It's that sentiment is far from the truth, right? Not only is Mary just absolutely loved by everyone at GM. I mean, I've heard people in plants say Mary's a rock star, right? She when she goes up there to talk, I think we all log in. It's that mesmerizing. She's very down to earth. She was an engineer just like us, grew from the ranks, being an intern at GM, working her way to the top, and reading her history and her bio, it's amazing to see. She was just like one of us, right? With no aspirations to be a CEO. It's just hard work that just led her there. And we definitely see her thumbprints, I would say, all over GM at this point. GM, the inclusive atmosphere, possibly can be attributed to her. She has made it a point to make GM look like a slice of the society that we live in. So society today, as we know, is made up of a diverse amount, you know, different cultures, different races, different colors, different sexes, all of that. So she wanted GM to look exactly like that, just a smaller version of society. And in a way, it helps GM as well, because the designers, if they have, if there's a diversity in every bit of how we're making a car, it's going to represent the interests of the consumer in the end. And at the same time, it makes it very easy for us to flourish, because we see everyone around us flourishing within the realm that she's created. The other thing she's pushed forward a lot is bring your whole self to work. Be yourself too, and bring your whole self. There's no reason to have a different persona at work and then be a different person when you go home. Just be yourself, right? That's the message. And I think that helps kind of loosen things up. Everything else falls away. You're just your own person, and you're there at work with everyone else. Those were huge changes. We are graded at the end of the year, when we do our reviews, our annual reviews are held, and the measures that they grade us against are what we call GM behaviors. And a lot of the GM behaviors are to do with all of these aspects of how we treat each other with respect, and how we are innovative but in a team, and then so the inclusive part of it. So it's so drilled in us that when you walk through GM, you'll sense it, right? Each one's treated equally, and it's really a very rewarding atmosphere to be part of. And then I can only see it going forward and becoming better. So yeah, but I would say that's Mary's touch.
That's awesome. That's really awesome here.
So along with what's happening in automotive, just knowing that we're in the midst of this amazing moment where things are moving so fast, and changing so rapidly in the automotive world, how is AM being incorporated within additive, within the automotive space? Carbon is well known for the work you do with the foam replacement materials, and we know of the midsoles and Adidas. But again, how are we seeing different materials like elastomeric materials being made possible to enable applications of tomorrow within automotive?
Yeah, absolutely. So on a larger scale, the automotive industry is shifting to really speed to production with this shift to electric vehicles. There's this massive race to get as many electric vehicles on the road as possible. You see some like pretty crazy goals from the large OEMs, GM included, with reaching all electric by X date. So rapid iteration is a really important part of the industry. So you're going to see a lot of companies trying to switching certain parts into additive manufacturing not just allows them to rapidly get to a final product, but also allows them to start production via the same technology as well. Because you have materials that can meet the performance standards of injection molded grade materials used today, which is great. But talking about the elastomers specifically, so a couple of months ago, we did a collaboration with the Adidas Seed Program, since Adidas is a huge partner of ours, and we were brought in with Lexus and Marvel as well to do a Black Panther inspired vehicle. So the Adidas Seed Program had like these really awesome ideas for the interior of the vehicle. So that's where we're kind of seeing a shift for some of our elastomers going into actual like interior components like headrests. We've seen a lot of work in lately. Speaker panels, center consoles, steering wheel covers, shift knobs. I mean, you name it. There's a lot of things that we can do on the elastomer side, not to just get this really interesting looks that you don't typically see. So like doing a lattice design for a headrest, there's components that you can do where we can do multi-zone lattices throughout the headrest. So we can have a section of the headrest that's more comfortable, and then a section that's meant more for impact. So there's things that we can do safety-wise there. I mean, really, it's just kind of limitless what we have the ability to do there, and I'm super excited to see where we go with that. So I would say that's that's one of the most exciting things for me right now in the automotive industry, is to see what we can do with foam replacement.
For so much focus at Carbon to go towards material development is very heartening for us to hear, because traditionally what we have seen with most of the technologies, at least in the polymer area, whether it's powder or filament, they weren't really made with automotive in mind. Our specifications, material specifications, which exist for today's parts that traditionally are made using injection molding, the existing portfolio of materials that's out there, again, back to powder and filament, doesn't even come close, right? It doesn't meet the properties. So it's very difficult for us to utilize those technologies to make vehicle components. Until we are able to find those certain applications which may allow the current portfolio. So to know that Carbon is putting so much effort in really looking as to how to meet the automotive specs, that's like the first challenge, right? That's really good to hear. So thank you for that.
Yeah, absolutely. It's certainly difficult. I mean, we're working with a lot of the OEMs to kind of figure out what their testing standards are, and then really putting our materials to the test and trying to meet those standards. And if we can't meet them, then our incredible materials team we have is able to make adjustments to the materials until we can get to the goal that we're looking at. So we see a lot of AM design incorporated into mechanical features of a car that many consumers probably aren't familiar with, such as brackets and fasteners. But how does additive manufacturing technology and materials impact auto design, development, and manufacturing in this way?
Yeah, so this, it's so tied to what I just said about certain materials not existing, but we're working very closely with material manufacturers as well as the equipment manufacturers, to see how we can move it closer to the goal. And with the ability to create materials that do come close or meet the requirements or beat them, I think suddenly there'll be an explosion of being able to use these technologies for vehicle components. Um, Automotive is different, right, from everything else that goes on out there. It's not like aerospace. It's not like manufacturing tooling. All of those are very low volumes, one-offs, maybe a few a year. But the moment you enter vehicle components, you're talking hundreds and thousands, and then so much is at stake, especially with regards to the material properties. Likewise, the other challenge that we have is meeting the cost models. Injection molding is well established. It's something that is a much better cost than additive. But that's not to say that additive will not be a solution for them, because additive allows for certain geometries which injection molding never can. And so it's important to find those applications which only additive can enable. And then the cost doesn't even matter, right? Especially if it enhances the experience or it enhances the assembly process, or if you can consolidate several components. So all of that goes toward why and how additive can fit in automotive. Another key thing, along with materials and trying to get the overall cost down, is the platform size of the machine, right? The bigger the machine is, again, we can make bigger parts or larger number of parts, which again, economies of scale, it'll bring down the cost. So we're looking at every possible way to either automate a certain process, definitely get materials and their processing optimized, working with the supply base that may have many machines that will be supporting, again, manufacturing of the future, working also at along with the equipment manufacturers and the suppliers, working with the secondary processing companies, the ones who will paint or coat or whatever needs to happen to that part. So there's a very large number of factors that come into play to enable what we are trying to do. And we're trying to attack it from every angle, and hopefully we'll, be successful at it in the end. So, but we're very excited at where we are, how quickly and rapidly we've grown, both in our knowledge and the resources that we have, and really the confidence of the company in allowing this to happen and knowing that this is the way of the future. So a lot has to be said about that as well.
That's really awesome. So I guess just kind of like to round it all out, what advice would you give to young engineers, designers, and other women in the industry? And like how, number one, how to survive in the industry, but then also how to thrive in the industry.
I'd say go in there and have, my mantra always is the technology is easy to learn. It's after you've got all that information, once you've understood what the technology is capable of, how do you take that and be inspired to apply it? It's not a man or a woman thing there at all. In fact, if anyone's more creative than the other, I think the women are way more creative. So use that creative energy. Definitely don't single yourself out because you're a woman, or you don't get intimidated by the males, as we talked about earlier. Everyone's entering the field at around the same time. And I think additive gives you the opportunity to be part of additive in many different aspects. You don't necessarily need to have an engineering background. You could have a materials background, a design background, electronics. I mean, it just, there's so many different aspects of being part of additive, that it's not just for engineers. So that's what I would say. What about you, Sophie? What would your input be as to the young engineers or aspiring engineers? Not engineers, aspiring candidates.
Absolutely. Yeah, I mean, I pretty much in alignment with you there. I would say like the most advice that I could give is just read everything, learn as much as you can. Learning about the different technologies out there, like the different powders, filaments, metals, photopolymers, just giving yourself the background and the basis to figure out what's the, not just like the one way to make something, like the best way to make something is just, it's powerful, especially in this industry. um so I would say that, especially like the designers, I think that there is such an artistic take to additive manufacturing, and I think that a lot of designers from arts fields will be just absolutely incredible in this industry and will only grow this even further. I mean, I see that a lot. There's tons of application engineers that I work with that are just incredible designers and make products that are just absolutely beautiful. So it's just be great to get even more of those type of people into this industry. But getting other women into the industry as well. I mean, if you like Legos as a kid, if you liked building Lego blocks or Lincoln Logs when I was a kid as well, that probably means that you have some sort of footing in a STEM field. So I would certainly ask you to just look at it and see what grabs your attention. If you want to draw something and then see it be made in real life, that you definitely have a place in this industry.
Such a good point. One of the challenges we faced early on as we were training or trying to train people to design using additive principles, they would take what they knew in metals, which was very geometric, and just try to do that in plastic or using additive. And it took a while to really put through the idea, make it organic, make it look like an amoeba, put in those curves, make it different, make it more for the task at hand than what you traditionally know. And it was tough for the folks that only knew one way, and we were bringing in something different. But if you can come in with that as your strength, as the design, the art aspect of it, I think it can go a long way. So you're absolutely right. I agree with you. So thanks for that, Sophie. We at GF are also trying to influence the next generation. and the ones that may not have the opportunities that are offered to us. So we have helped some high schools in the Detroit area, given them machines, we train them. We even bring in students from a high school. And there was one young lady who was with us for 2 years, where she came in twice a week and assigned, we would assign some work to her, and she got more familiar with additive. And it's exciting to know that she takes this information back to her high school, and we're just grooming the future and getting the interest there. And that's very, very exciting and very fulfilling to see that come together as well.
Oh, that's awesome.
Thank you so much, both of you. You didn't know this, or I don't know if you knew this, but I actually started you 10 minutes earlier than what you were supposed to come on. So, and you know what, in hindsight, I'm really pleased that I did, because the two of you have been able to fill this time completely beautifully. And I'm very pleased that you got the extra 10 minutes. And we also have quite a few questions up there in the Q&A. So I might just go and start working our way through them. Do you feel that there is more opportunity for 3D printing in end-use parts or manufacturing aids for automotive? That's from Andrew, who also works at Carbon.
Yes. Well, since I work with Andrew, Melanie, if you want to answer this one, you're more than welcome to.
I'm sorry, I missed it. I'm looking for the question now. Could you please repeat that? What about the manufacturing tools?
Yeah. So is there more opportunity for 3D printing in end-use parts or in manufacturing aids in the automotive industry?
So it's very easy to what I would call justify manufacturing tools. Again, because you're just making one or two. When I say justify, we're looking at cost justification. We're looking at the turnaround time. And right now, the way additive is poised and the way automotive is poised, where there's a race to the top, especially with regards to EVs, the big push is lead time reduction. So we're constantly looking for where exactly does additive fit in best. And we find that we can reduce overall lead time from 12 to 16 weeks to down to a matter of days. And so that additive plays a big role in customizing the tool and really cutting down the lead time, which is what the industry is looking for right now.
It's really interesting to hear. I guess, so much of the experience with automotive in the past has been it's all a bit about cost reduction, like a heavily cost-driven industry. And now it's, interesting to hear it's actually shifting towards more of a lead time industry. Yeah. There's another kind of cute question. What are each of your favorite cars, and what's your favorite AM part that you've seen on a car?
All right, I'll definitely take this one. So my favorite car would be a 65 GT 500 Ford Mustang. Sorry, I know it's Ford,
okay.
But I would say that's definitely my favorite classic, tied with a 69 Charger as well, Dodge Charger. But yeah, there's a lot of cars that I thoroughly enjoy. But favorite AM part that I've seen on a car, I mean, definitely, I think the headrests from the Lexus project are one of the coolest parts I've seen on a car. But one of the coolest things that I've seen car related that I didn't expect that was 3D printed was on an Electrify America station. Where you actually put in the charger plug that I guess the holder I realized was MJF made. And it was just while I was charging my car one day, and I was like, to see like a 3D printed part just out there, I was like, that's really cool. I always love seeing that type of stuff. So that's my answer to that one.
I think it's
always I drive a Buick and I love it. So I'm going to stick with that. Yeah.
Tell me you get a staff discount, Melanie. I think it's always fun when you can spot a 3D printed part, out in the wild,
Yep.
When you look at something, you're like, that's 3D printed. Like,
Yep.
It's always very rewarding. How do you handle pushback from users who think that AM just can't be right for them?
You want to take it? Okay, so we face that constantly, right? They in fact, the very first time we pulled in all our suppliers to try and at least give them an awareness and an understanding to see how we can influence the tools of tomorrow, they push back. They each one stood up and gave us a big list of concerns as to why we are wrong, and it was each of those concerns were really valid. They were questions that we didn't have answers for at that point. So I would say it was probably our worst meeting, but it was also the best meeting. It was where the pivot took place, where we took all their concerns and really got to work, got the task done as trying to answer it, because without those answers we won't be able to create what we are trying to do. So and so everything that they mentioned allowed us to do a deep dive and really answer those questions and then enable those applications of tomorrow. So there will always be pushback, especially from folks that are experts in the field, and you're telling them that there's a different way, and suddenly they feel that they're not needed. But the other thing that really helped is once you're working with them and something is successful, to give the credit to them. Let everyone know what they just did, even though they were opposing it at first. And that's something that's worked so well because they themselves are inspired to influence the next set of AM applications.
That's great. All right, well, we're going to wrap up now. There was 2 extra questions, but I'm sure these one will be around in networking if you wanted to go and hassle them about the questions that you had. Thank you so much for such an enlightening conversation, such a beautiful, relaxed little chat between these 2 women in the industry. One of the questions I had is, how do you know each other? But we're going to save that for maybe afterwards.